We are starting with session 1 of day 1, Introduction to Image Processing and its Applications. Dr. S. Margaret Annuncia, Professor and Director, Faculty and Staff Welfare, School of Computer Science and Engineering, VIT University, will be presenting this session. I hand over to you, ma'am. Kindly proceed.
Thank you, Dr. Anupriya. Is it fine if I switch off the video?
It's okay, ma'am, because you are sharing the presentation. It's fine, madam.
Yeah. Very good morning to one and all. The present topic, an insight into digital image processing and its application, it's not new to any of us. And of course, as soon as we think of any research ideas, the first and foremost idea or the first and foremost domain that comes into our mind is image processing. By passion or by curiosity, or sometimes because it is being followed by number of researchers, we generally get into the habit of selecting this image processing as an area of research. Whether we have an interest or not, we just try to explore it. But looking into the field as such, this is like an ocean where we have ample of research ideas, and as the technology is developing today, a lot of applications of this digital image processing or video processing is becoming more demandful, and hence the researchers will have a lot of opportunities to dig into it and to come up with wonderful ideas. To get into that particular ocean, we need to understand what exactly is the concept of digital image processing. Is it just like what we are doing with Photoshop or a Paint or any other, any other image processing tools, or is that includes any ideology that we need to work on with? Generally speaking, it is an interesting area where we will be able to understand a lot of things, and accordingly we may be able to proceed further into the research, and lot of research ideas are also available in this particular domain. Having said all these things, let us understand the fundamental concept of image processing. If you just look at this image processing as a hobby or a passion thing, it involves just the modification of the pixels with respect to the application, and then we try to make up the image as an original one, and from there we try to learn something. And if you look into the research perspective, there are a lot of processing involved, so which will be making the image as a more visualizable one, so that the understandability towards the image and getting the inference out of it is becoming very popular and more. So with this introductory note, let us get into this. And this is not going to be a new ideology. This is just a refreshing of the ideas behind the traditional digital image processing that is being followed. But of course, I'll be giving some ideas here and there where it can be applied effectively for our research. Getting into the presentation. So the first few slides will be discussing about image and its types and what are the different modalities that are available in order to get into the image processing. And then what exactly is the image processing and what are the steps involved in. And we will be looking into each steps elaborately and what are the different applications, and finally image processing tools and libraries that are available for today's usage. Coming to the image. So as we all know, the image, am I audible?
Yes, ma'am, you are.
There is no disturbance, right? I just feel some disturbances over here. Okay. Image is a two-dimensional rectilinear array of pixels. And image can be defined as a two-dimensional function f of x comma y, where x and y are the spatial coordinates, and f provides the amplitude of any pair of coordinate x and y, which may be called as the intensity or a gray level of an image at that point. And x and y and f are the finite and discrete quantities. This fundamental definition most of us know. And ultimately, the image is going to be a matrix of coordinates or matrix of values, and each value is representing the intensity, which normally depends upon the size of the image. If it is an 8-bit image, then all the intensity will be between 0 and 255. If it is a 16, accordingly it will be varying. So finally, an image is going to be a two-dimensional array or a matrix of pixels, which is going to have an intensity or a gray level value. Coming to the different types of image, normally we come across a color image, binary image, and index image. And in between, we used to have a grayscale image, which will be purely a manipulated one of a binary image. Now coming to the color image, what exactly is a color image? Here, each pixel contains a vector representing the primary color of red, green, and blue component. So you can very well find out here RGB components, and the combination of RGB is leading to the different colors, and that is helping us to represent the colorful scenario of any of the image. So ultimately, if you look into a color image, it's going to be a combination of red, blue, green, which we all know. And the next one is going to be a binary image, where each and every pixel will have either of these values, either 1 or a 0. 1 will be representing the white component and 0 will be representing the black component. There is a slight variation on this binary image, which is leading to the grayscale image, which will have the combination of black and white only. So you will be having between white and or between black and white, the different combinations that can be obtained through the composition of black intensity values and white intensity values will be forming your grayscale image. You will not have any other color beyond this black and white, the composition or the components of this black and white together. So that is the grayscale image that we normally don't represent it as a separate one. It is a part of it. And the last one is a indexed image. Each pixel contains an index number pointing to a color in a color table. This normally, if we are dealing with the different levels of different modalities of images, we wanted to have some sort of normalization. So we prefer to generalize the appearance of the image or generalize the values that are present with the images, and that's why we normally go with the index image, where you will be having for each and every location of a pixel what is the combination of a red, blue, green, and accordingly we try to establish a color table from where we will be processing the images. And then today we are coming across, this is a 2D representation, and of course with depth exploration, the 2 dimension have been converted into 3 dimension, 4 dimension, and presently we are into the 5 dimension view. So when you talk about a 2 dimension view, it is going to be a x comma y only, and in the case of 3 dimension, not only the height and width, it is also going to take care of the depth of the pixel, and subsequently with the 4 dimension and the 5th dimension to explore the vital values of each and every point, and so that the visualization can be made in a better understandable form. And especially in the field of medical science, we make use of a 4 dimension and a 5 dimension kind of representation, which is helping us to understand the nook and corner of the image. From there, we try to get the information about the detailed information about the depth point. So that is very helpful. On today's scenario, most of the medical devices or the medical field, they make use of this 4D and 5D. And 2 dimension and 3 dimension are also being used. And wherever we come across any kind of quality testing, we make use of this 2 dimensional and 3 dimensional images for the exploration, for analysis and understanding. Now, next one is, what is image processing? It's a simple, it's a transforming an image into a digital form and perform certain operations to get some useful information from it. Whatever we do with an image, it turns into a useful information only. And so the image that we receive in a 2 dimensional form will be subjected to certain operations, subjected to certain manipulation, and out of the manipulation we try to get or extract the useful information without distorting the originality. And sometimes with the original distortion, we take up the information but keep up the original answers. So now if you just look into the image processing, what are we expected to do under the image processing? Any kind of research if you take with the image processing, that will be around this 5 different domains only, subdomains. The first one is visualization. I just wanted to visualize what exactly is present in a particular domain. I make use of an image. From the image, I try to understand what exactly it is, how the representation of an object is going to be, and how it is going to be visualized. Each one of us will be having a different perceptions and different visual ability. So if we wanted to have a proper visualization of a certain things or an object, it need to be represented appropriately, and not only the representation, it need to be interpreted appropriately. So the proper representation and the visualization, the image processing is helping us to get a proper visualization of a certain thing. The second one is the recognition. So what is that recognition? Yeah, I have an image in front of me and there are a lot of objects available. And how do I identify each and every object? Whether they are belonging to the same domain or the same aspect, or is it of a different one, and by what feature they differ from each other, and how it is going to be helpful for the usage. So that is what normally done in the case of a image recognition. And the third part is the sharpening and restoration. Maybe I can say this is an older one, and a lot of research have been carried out with this sharpening and restoration. And without knowing what we are carrying out, we normally get into this sharpening and restoration. And it's like when an image is presented in front of us, and if it looks somewhat unclear, or if it is not, the clarity wise, if it is not acceptable one, then we do some sort of manipulation without knowing what we are carrying out. We try to sharpen the image and then try to go for the understanding. So normally we meddle with the photo processing, this kind of sharpening operations only. And in today, if you see, lot of apps have come up with this sharpening and restoration. And even the children are used to play with a lot of sharpening mechanism. So that is a traditional one, and now in day-to-day events, we are becoming a part of it as we get to use all Instagram or any kind of social media for posting the pictures. We make use of this particular technique. We adopt extensively, and we make use of this particular technique of sharpening and restoration to a maximum level. And next one is the pattern recognition. And this is where the challenges appears. It's not going to be like a numerical data that we are going to analyze and come up with a conclusion. It's going to be a representation of some real data in terms of the intensity, which need to be appropriately interpreted. And this pattern recognition mechanisms normally it is helpful in the satellite image representation and satellite image interpretation and medical image interpretation. The pattern recognition plays a vital role. And as far as these two particular domains, subdomains, or the applications of image processing is concerned, the sensitivity of the interpretation is more over here. And so if there is a problem with the interpretation, everything goes off. So we have to be very careful and arriving at an appropriate pattern level and interpreting it as it's got a lot of challenges in it. And that's why even now, lot of research is appearing towards the pattern recognition. And last one is retrieval. In the earlier days, we used to have the retrieval of image based upon the statistical features or some kind of manipulation towards the statistical analysis and understanding of the pixel values, and based on which we try to retrieve certain portion of it. But as and when the technology has grown, lot of information are being represented through the pictures or the images, which has got a different level of understanding and different level of interpretation. And it's not enough to have a statistical based retrieval, and that is not going to be of accurate one also. So if we want to improve the retrieval rate, accuracy of retrieval rate, there need to be inclusion of semantics with the image features. And when you include all those things, semantic based object recognition and object retrieval, that becomes mandatory. And nowadays, this is becoming popular. And so the retrieval mechanism is gaining importance and momentum in the field of image processing research. So if you just look into this 5 different area, presently the visualization, that is the different levels of visualization, different forms of visualization, it takes up booming ideas and retrieval with respect to the semantics. So far we had been retrieving based upon certain uh, nomenclature or a certain feature which are available, only that much. But nowadays we require by means of the individual features, the tagged annotations, we wanted to retrieve the entire images, which is of going to be useful for different purposes. So the visualization and retrieval is gaining more importance. And of course, the pattern recognition, which is in the field of medicine and in the field of remote sensing, it is becoming a vital. And nowadays, this pattern recognition is very much helpful for the IoT based applications too. And of course, the recognition and sharpening is going to be a part of all these things. But as far as the research is concerned, the visualization, pattern recognition, and retrieval is gaining more importance and momentum nowadays. Now, coming to the fundamental steps. So, if you wanted to have these research areas of visualization, recognition, sharpening, and pattern recognition retrieval. We need to understand certain fundamental operations that could be carried out with respect to a particular image. And of course, the image modalities, you have compressed form like JPEG, and a BMP one is available. And of course, the BMP will be taking lot of storage. If there is a want of storage, then we would be processing up with the JPEG, the compressed version of the images. And if at all, if the research need to be carried out effectively, for a better understanding of any of the image, BMP format would be useful, but it takes a lot of storage spaces. That is the disadvantage of having a BMP. On the other side, if you wanted to have the better understanding and better processing of the images, the compressed version of it, which is leading to JPEG, would be of useful. And with the fundamentals of this, we come up with the different standards, and of course DICOM standards are available for the medical informations, which is helpful for the processing. Whatever be the modality and whatever be the type of image that we are having, the fundamental operations are going to be similar. And let us see the fundamental operations one by one. So as in any application, image processing is also going to have some kind of acquisition system by which the input is going to be taken from the external environment, and that will be moved forward for the further processing. Whatever be the type of application we have, in the normal data applications, we collect the data, we acquire the data from the user, and the data will be analyzed. And instead of saying it as a data here, I'm considering it as an image. So that is the first step which is involved in a problem domain. And of course, all the images that are acquired cannot be processed as such, because when we are acquiring the image, we may come across certain issues, and we may not be able to record the image exactly in whichever form we want it. So we may come across here and there some sort of deficiencies. How do I come up with that such deficiencies? We make use of certain enhancement technique. And there are some, it's not always we are going to work on with the images that are currently going to be acquired and used as such. We may be using a older format images, or we may be using a image format that may not be presently widely used, and so on. So if at all, if I wanted to perform, we cannot omit such images also. We need to perform certain operations over it, if at all, if it is required. So in that case, we need to restore the format into the current form such that it is helping us to proceed with the current technology based processing. So that is available with the image restoration. And of course, the color image processing. And always we are not going to deal only with the grayscale image or a black and white images. Now the things are represented in the multi-dimensional form with the multiple colors, and so the color image processing would be of very much useful. And then whenever we have representation, mostly we try to operate with a spatial domain. That means we just identify the pixels with respect to the locality, and the intensity values of these pixels will be manipulated or altered such that the understandability of the image becomes very much useful for us.
एउटा attendance डाकिबो बोली कहले त सुन्छ.
Participants, please mute yourself.
Shall I proceed, ma'am?
Ma'am, please proceed, ma'am. Tunirani Nayak, please mute yourself. Yes, ma'am. Please proceed, ma'am.
Yeah. So then sometimes, the spatial processing may not be helpful, or it may not be yielding the accurate outcome whichever we expected. And sometimes it is very tedious to identify which of the location is going to have a problem. and identifying that, locating that, and manipulating that may not be yielded in a generalized format. So we need a better opportunity or a better mechanism to deal with such kind of things, and that's why we move into time and frequency domain. So if it is necessary, then we would adopt a time and frequency domain for identifying the deficient areas in an image, and accordingly it need to be more, updated so that that is improvised, so that the details are becoming very much visible as well as the details are available for us to the further processing. So that is done with the wavelets and the multi-resolution processing. Normally this is another powerful domain within digital image processing, where you will be analyzing the image with respect to the time and frequency domain processing. And the next one is the next step involved is the image compression. The size of the image is a challenging one, and it is varying from even a smaller size to the larger size. And analyzing a smaller sized image and storing the smaller sized image is not an issue at all. But as the size grows, having it inside a single frame and analyzing it to get all the details is becoming challenging. And sometimes when the size is becoming larger, we need to have a more number of frames, which will provide some sort of discontinuity in analysis. And so if you want to analyze it in a proper form with a single frame or with a single mode of representation, then the compression would be of helpful. So you are going to compress the image. Sometimes it is with the loss of some data or without the loss of data, that we will see. So we compress the image and make it as a available size, which may be easy for us to that is to achieve portability from one platform to the other and from one media to the another. That is becoming easier. So image compression is helping us in that one. And the next one is of a morphological processing. So most of the medical applications will have this emphasis over the morphological processing. So if I wanted to know the complete details and the in-depth details, I would go for this morphological analysis. And for that, the morphological processing would be helpful. So in that particular thing, if you just look into the representation, acquisition, enhancement, restoration, processing, and multi-resolution processing and image processing, multi-image compression. This would be producing the output in the form of an image only, and the image for the better understandability, for better analysis. And if you just look into the other side, that is in the right hand side, whatever I have represented as a morphological processing, segmentation, representation, description, and object recognition, these are all will be providing certain image attributes that will be helping us to go about the image analysis and interpretation in a better form. So though it yields a certain outcome as an image, the features are more important than the image format that we are obtaining at these stages. And these features will be helpful in deciding about the different interpretation level. And whenever you wanted to have any sort of recommendations or any sort of conclusion to be available for any of the image, these processes will be helpful. So let us go into each of these steps in detail. The first one is the image acquisition. So as we all know, the object of interest or the region of interest is going to be eliminated, and through the sensor, the image is captured. And then the captured image, if it is acceptable or if it is directly available in the digital form, we go ahead with the further processing. If it is not available in a digital form, well, in the earlier stages and all, earlier maybe a decade before or 2 decades before, we used to have analog images only. So those images will be taken forward and that will be converted into the digital form, and then only it will be proceeded for the further processing. So the image acquisition, the image is captured by a sensor, and as far as the terminology that we adopt, it's nothing but a camera. And it is digitized if the output of the camera or sensor is not available in the digital form. Using an analog and a digital converter, we make use of it. Otherwise, we directly take up the digital data and we proceed with that. So for earlier and all, we used to have what is called analog format, means we used to acquire the image and then that need to be converted into a digital format. For example, X-ray and all, it will be available in the film, and the film, from the film we need to grab the image and those details need to be converted into the digital form. And presently we have the digitized output for the X-ray film itself, and that is helpful for the further processing. Okay. So earlier we were using a single sensor for acquiring the images, and after the certain duration, we have come up with what is called as a line sensor. But what is being currently applied is a array sensors, and this is the one which is being for a decade onwards. We are using those array sensors only. No, more than that. The two types of commonly used image sensors are CD and CMOS. And in some cases, we adopt or we make use of CCD. And in some cases, we just go ahead with the CMOS based cameras by which the image will be acquired and processed. The second process that is going to be carried out in the image processing is the image enhancement. So if you just look into this diagram, there is some sort of unclarity is available in the image, and when it is subjected to the image enhancement, the clarity of the image is being improved. So that's what normally we look at the image enhancement. From the name enhancement itself, we can identify easily there is going to be some sort of enhancement. And especially this enhancement is going to take place with respect to contrast and the brightness. Contrast level and the brightness level of an image, such that the clarity on the image is going to be obtained. So that is what we normally get in this particular operation. So the image enhancement, it is nothing but the process of manipulating an image so that the result is more suitable than the original image for the specific application. The idea behind enhancement technique is to bring out details that are hidden or very simple to highlight certain features of interest in an image. And reason for doing this is sometimes we wanted to highlight a particular portion of an image. So only that need to be projected. And if it is not going to be appearing in a bright format, or it is not going to be available in a focused format, then we need to slightly improvise the focus of that particular region so that it is becoming more visible when compared to that of the rest of the features. That means it is gaining certain importance. So in such cases, image enhancement can be used. And the second one is when you have a certain unwanted portion in the image. Normally we call everything as an image, noise. And when we have certain unwanted portions in the image or certain things which is creating unnecessary interpretations and the misinterpretations on the images need to be reduced or to be avoided completely. So in such cases, we try to enhance the image in such a way that the presence of this unwanted things becomes very less, or sometimes it is suppressed to a maximum level. And the third one is This image enhancement techniques makes the images more visually appealing. So that is the reason why we go for it. And what is the need for this image enhancement is maximum it is dealing with the poor contrast and due to the poor illumination or a finite sensitivity of an image device. So that is first and foremost idea for which the image enhancement is normally used. Sometimes the illumination is not proper or if a light, the reflections is not proper on the object, or if the object is not in a appropriate direction to receive the light, the images that we are getting may not be of a appealing one. So in that case, we may have to go for an enhancement. And the second reason is normally this noise. See, whenever we acquire the images, we make use of the external devices from the system. And when we use the external devices, the compatibility of the external device with the present system or our system may not be that much compatible. So in such cases, what will happen when we are trying to acquire due to the compatibility issue, certain things may not be recorded clearly or certain things may be recorded in a different form. So those things normally we call as a noise or the atmospheric disturbances. And these disturbances need to be removed or suppressed from the images. But before we carry out any processing or of any application, these noises need to be suppressed or these atmospheric disturbances need to be completely avoided. So that's why we normally go with the enhancement. And third one is a aliasing effect. Aliasing effect, it is normally some sort of, it would be looking like we would have come across something like a blurred kind of appearance or some sort of checkerboard appearance that we call it as aliasing effect, a staircase kind of effect where the representation of the pixel may not be appropriate, so that it provides a blurred appearance of the object. So that is a aliasing effect. So to avoid all those things, we normally go ahead with the enhancement. The enhancements can be handled with respect to two different major technique. One is spatial domain technique and another is a frequency domain technique. The spatial domain technique, it's a direct manipulation of image pixels. We identify the locality of the image pixels and then we modify the pixels accordingly so that the improvisation on the visual part is getting done. And the second one is a frequency domain techniques, which is going to be happening with respect to the transformation or the transform of an image. And generally, we carry out it with respect to Fourier transform or with respect to the wavelet transform. So these techniques identify the frequency of the dull portion and accordingly the frequency will be altered. And sometimes the dynamics of the appearance, the dynamicity associated with the pixel can be easily identified in this frequency domain, and that can be altered accordingly by adopting the appropriate procedures. That is helpful. So coming to the image enhancement techniques, there are number of techniques are available, the spatial domain techniques and the frequency domain techniques. And these techniques are repeatedly being adopted or commonly used techniques. The first one is a point operation, and the second one is histogram equalization and matching. And third one is a power law transformation. And fourth one is the gamma correction, and fifth one is the contrast stretching. So if you just look into this, all these things are associated with the spatial values or the x and y pixel values with respect to the locality. So that is the spatial domain techniques. And coming to the next one, you have unsharp masking and homomorphic filtering. We are having lot of other techniques also. These are all commonly used techniques. Now coming to the point operation. So what exactly we do with the point operation? We take up a pixel. Say for example, if the pixel is located at a location x comma y, we take up that particular pixel and we compare it with the neighboring pixels. So the neighbor 9 pixels will be compared. So 8 pixels will be compared. And if this particular pixel value is having lesser intensity than that of the other 8 neighborhood, and accordingly this particular pixel alone will be increased. That is the manipulated. So that is a point operation. We try to locate the exact location where the dull pixels are available, and the dull pixels are manipulated to have a new intensity values which is more or less equivalent to that of the neighborhood. That is what happening in the case of a point operation. The second one is a histogram equalization. We all know the histograms are helpful in projecting how many pixels of a particular intensity is available in the image. So when you generate the histogram, we will come to know whether the image is of a low contrast one or a high contrast one based on the skewness of the histogram that we are obtaining. If it is very much skewed towards the left hand side of your histogram, then probably we would state that particular image would be of a low contrast one, and so we need to stretch up the contrast level to the right hand side also. So more or less it is improving the contrast level. So the histogram equalization helps us to understand what type of image it is, whether it is a high contrast image or a low contrast image. We need to optimize that contrast level so that the visual features are very much available for the better understanding. And for that purpose only, we make use of this histogram equalization technique. Maybe in a simpler word, I would say we are normalizing the presence of the intensity so that the image is clearly represented for the further processing. Third one is the power law transformations. We know that when it is exponentially increased, how the intensity values will be increasing appropriately. And so definitely there is going to be a improvisation towards the contrast level, and that is what we normally get out of this power law transformation. And gamma correction is whenever, normally when you have, especially in the corners or in the poor light or illuminated portions, we will be having very low intensity of the images. So when we do this gamma corrections, the minute details which are available at the dull locations or the corners of the images also will be improved. And the last one is a contrast stretching. So if I have the contrast level between a certain intensity level, if I extend it to the maximum, the visualization of the image will be very clear when compared to the previous one. That is what normally we do in the case of a contrast stretching. And coming to the unsharp masking. So in the frequency domain, if you just happen to see how the signals are represented for the images based on the frequency, you can find out in certain locations wherever we come across a very dull frequency. So that will be easily visible for us when we do this frequency analysis, and that need to be masked, and so that portion will be filtered out and the rest of the things will be taken for an account. So by that way, the low detail or the low values will be omitted and only the clear portion of the image will be considered for the further thing. And similarly, the homomorphic filtering is also helpful in diluting all this kind of unwanted or a low frequency pixels which need not be considered for the further analysis. The rest of the important one will be considered for the analysis. And the next one is the image restoration. As far as normally we get confused between the image restoration and image enhancement. Enhancement is something we deal with the brightness and the contrast of the image. And the restoration is the one where we try to reduce or avoid the external disturbances or the noises that are intruded into the image in the form of a pixel. So we will be having unusual pixels across the image pixels, and those unusual pixels need to be carefully identified, and the effect of that unusual pixel need to be either reduced or completely avoided. So that is the purpose of a noise reduction. So the source of noise in a digital images arise during the image acquisition and the transmission. Maybe due to the transmission media also, we may get into number of variety of noises, and those need to be suppressed or need to be avoided. So imaging sensors can be affected by the ambient conditions, and inference can be added to an image during acquisition or transmission, which is leading to the unusual or unwanted pixel inside the images. Am I audible?
Yes, ma'am.
Ma'am, you are
Yes, ma'am.
audible.
No disturbance, right?
No, ma'am, no.
So there are different types of noise that are available, and of course, based on the type of noise only, the level of enhancement and the restoration need to be carried out. So the common one is the salt and pepper noise, which is nothing but the addition of white pixels and the black pixels and sometimes the gray pixels unwantedly into the images. So sometimes this addition of white and black pixels will have better clarity on the image, and sometimes it will not have, it will lead to the misinterpretation, and anyway it need to be suppressed or reduced. The most common noise that is normally available with the image is the impulse noise or the salt and pepper noise. That unwanted white pixel, unwanted gray pixel, unwanted black pixel need to be removed. So that is the first thing. And the Gaussian noise and addition noise, these are all based on certain specific aspect which is happening due to the transmission error or due to the acquisition error. And the fourth one is of image blurring. That normally we know that when the sensitivity of the acquisition media is not appropriate, then we get a blurred image which need to be corrected and which need to be processed. In some cases, there is a possibility to go ahead with the new set of images. When it is not possible, we have to restore the image and then we have to process the image. So in that case, this mechanism, the image blurring, can be avoided by means of a certain enhancement procedure. And apart from that, you have gamma noise, exponential noise, uniform noise, and periodic noise. As the name states, based on the feature, certain things are increasing, which is of increasing order or a decreasing order, or for a periodical interval of certain location, you will be finding certain unwanted pixel into it. Those need to be removed. And so the image restoration attempts to restore images that have been degraded, and this normally goes ahead with the degradation process and finally trying to attempt to reverse it. So actually in the case of enhancement, what we normally do is whether it is a useful pixel or unusual pixel, we try to improve its contrast level or brightness level, and through that we try to seek whether there is going to be an improvisation towards the clarity of the image without knowing what is to be done over there. But here in the case of image restoration process, what we will be focusing is, we wanted to know what has made to have a degraded representation of the pixel in that particular location, and identifying the degraded process or the degraded reason. Then we try to recover that pixel's original value or the pixel's improve the pixel's intensity after identifying the degradation process by providing the appropriate measures to the degradation process. That's why we have here I have mentioned, first we need to identify what made the pixel to have a degraded representation over there. Degraded representation means it is not on par with the rest of the pixels, or the rest of the regions are having a better contrast level or the better brightness, whereas this particular portion is very dull in appearance. Why this appearance degradation has happened? What made to happen? It may be due to poor illumination, or it may be due to the longevity of the image that we are keeping up with that, or the photograph which have been made available may not be having a proper standards to store it or proper standards to acquire the image. Lot of issues are there. So what is the exact reason for the degradation process? And after having identified the degradation process, we try to attempt to reverse it. So that is what happening in the restoration. Whereas in the enhancement, irrespective of what type of problem happens, we try to enhance the contrast level and the brightness level. And in the case of image enhancement, it is more of a subjective in nature, whereas the restoration is more of objective in nature. So enhancement is largely a subjective process, and prior knowledge about the degradation is not a must in the case of enhancement. And we make use of heuristic procedures and take advantage of the psychophysical aspects of a human visual system, and based on that we try to proceed. That is happening in the case of a enhancement. Whereas in the case of a restoration, it is more of objective, and we try to recover the images by using the knowledge about the degradation. So what is the real problem which has brought this particular pixel to be of a degraded one, or a particular region to be of a degraded one, and based on that we try to adopt a mechanism by which the images are restored. And what are the different methods available for image restoration? So these are all not new for us. Already we are having it, and most of us would have used it. Anyway, I have listed out what are the restoration methods we have, like arithmetic mean filter, geometric mean filter, harmonic mean filter, contra-harmonic mean filter, and spatial filters like a median filter, max minimum filter, midpoint filter, alpha trimmed mean filter, and additional filters are available, where band reject filters, where the low pass and high pass band based upon the need to be rejected, and sometimes the adaptive filters. Maybe we can identify certain thresholding value, and for each location, depending upon the way the images are, the pixels are represented, we try to adapt adaptive filters and adaptive mean filters. The average of the neighborhood pixels will be taken, and it will not be going to be uniform throughout the image. It is going to be dynamic based upon the neighborhood available. So these are the different filters that are available, and normally all these filters are functions based upon the statistical features that we obtain, the mean, median, and variance. Based upon these three concepts only, most of these filters would be worked. So if we are familiar with these concepts of statistical functionality, handling with the image restoration and understanding the image restoration is becoming very easier. So you can see the different, when you apply the different level of filters, what sort of outcome you are receiving. Coming to the next one, color image processing. And more than handling with the black and white image processing, that is a monochromic image processing, or with the grayscale image processing, where the level of analysis and understanding is limited, mostly we used to enjoy with the color image processing, because you will have an ample of combinations, color combinations, and it is sometimes quite interesting to go ahead with that. And when you do certain manipulations, we come up with the surprising combinations, and which will be attracting the users also towards it. And so a lot of other researches are happening with respect to the color image processing. So coming to the different, one aspect, if you just look into the color image processing, a variety of applications are there with the grayscale image processing. And of course, we all know the full color image processing is becoming very vital today. And that is also possible. So what is that the color processing is going to handle with? Color processing is going to handle with the three different aspects. One is a color model, second is a color space, and then the third one is going to be of a color system. So these are the three things that we need to understand as far as dealing with the color processing. The first one is a color model. It is a method of describing a color. Generally, we all know the common terminology. As soon as we hear about a color image, the common thing that is coming to our mind is the RGB values. It's not only RGB value is going to be useful. There are other combinations are also going to be useful in the color processing. The other combination we can say the cyan, magenta, and yellow. These three are playing an important role in the getting the next color model. So you can see here RGB model, CYM model, CYMK model. That is RGB is a primary one. And then you have what is called as the cyan, yellow, and magenta model. And the third one is cyan, yellow, magenta along with a black. The last one is hue, saturation, and illumination. That is the last part. But as far as the color models are concerned, these three things will be defining the intensity of a particular pixel, and HSI will have how deep the intensity need to be represented. And you can see here the RGB model, how the combinations will be done, and here also. Normally, when this makes use of the cyan, magenta, and yellow are considered to be the secondary colors of light, and based on the mixture of these two, primary and the secondary, we get some combinations that normally we use it.
Ma'am, there is one small question
Yes.
from the person. Like they wanted that filters, no, like the usage of the filters to be repeated once again, ma'am.
Okay, no issues. Yes.
Ma'am, you can
So-
focus even at the end, ma'am, no problem. But just I'm just informing you, there are a few questions related to the, you can do it at the end, ma'am, no worries.
Okay.
After you finish your presentation.
Okay. So as far as HSI model is concerned, the hue is a color attribute and saturation is purity of the color, and brightness that is the illumination part of it, the third I for illumination, achromatic notion of intensity, how far it is brighter enough to represent itself. So it's quite tricky, as well as sometimes we get confused with what is this brightness and the contrast. The contrast will be indicating the overall quality, and the brightness will be with respect to a particular pixel, how much of depth of intensity is available. Based on that, we try to improve the depth, by means of which the entire brightness is going to be improved. So the hue is going to be a color attribute, and saturation is how far it is oriented or inclined towards whiteness or the primary colors of your light system. And then the achromatic notion of intensity with respect to the rest of the pixels. So you can find out here how exactly it is represented. And next, coming to the color space, it is a set of colors which can be displayed or reproduced in a medium. How it is going to be stored or printed or displayed. Normally, whatever we are seeing as such may not be reproduced, and we need to map it along with the appropriate color space. Say for example, if you take a 8-bit image, you can have a color space of around 256 different combinations. And if you are going for a 16-bit, 2 to the power 16, that is around 65,000 combinations would be available. And so we will be having, if the whether the, for example, if you have peacock blue, so normally it's going to be a combination of blue and green with a certain proportion, and directly with a limited amount of color space, it's not possible to exactly reproduce the peacock blue. So if you just combine the blue and green together with certain proportion, if the blue is dominating, it will be appearing as a blue shaded color. And if a green is dominating, it will be appearing as a green shaded color. The one which we had in our mind is the peacock blue, which is going to be a more or less optimized combination of blue and green with some other composition, so that it gives a shiny blue shade. So in that case, the whatever we conceive in our mind cannot be brought for a display or cannot be brought as such for the printing also. So we need to define under which particular color space this would be more possible. It's not that we don't say that it is not possible at all. The peacock blue may not appear as a peacock blue when it is getting printed out, because the color space that we are adapting for our system may not be catering the need of bringing out the peacock blue as such. So we need to fix up what sort of color space that we are going to adapt in order to reproduce the images in the appropriate form. So that is what normally defined through the color space. And next one is the color system. This is also which is associated with the printing and on-screen design mechanism. You have CMYK and Pantone, RGB and RAL. These are all the different color systems that are generally being used. So that you have a lot of ideas over it, and maybe for the want of time, I'm not going to elaborate it. We just understand what exactly it is. Maybe later onwards, we can explore it in a better way. And next one is the wavelet and the multi-resolution processing. So wavelet is a small wave, and as far as the wavelet transforms are concerned, it converts a signal into a series of wavelets. and it provides a way for analyzing waveforms bounded in both the frequency and time duration, and allows the signals to be stored more efficiently than by the Fourier transform, and it is helping us to get a better approximation of real world signals and well suited for approximating data with the sharp discontinuities. Normally, this wavelet and the multi-resolution processing, these two are very much effective in the field of signal processing, and those who are working on with the spatial domain processing may not have very much detailed information on this, as it is involving the signal processing. But as far as the wavelet and the multi-resolution processing is concerned, the better approximation is possible with respect to the signals. That is the benefit of this wavelet. And coming to the wavelet transform, an alternative approach to the short-time Fourier transform to overcome the resolution problem. And multi-resolution analysis, it is analyzing the signal at a different frequencies with the different resolutions, and the good time resolutions and the poor frequency resolutions at the high frequencies, good frequency resolution and poor time resolutions at the low frequencies. Especially these two aspects are dealt with respect to the multi-resolution analysis. The time factor and the poor frequency, and good frequency resolution and the poor time factor. These two are complemented version of these two things are handled. And what will happen at the higher frequency level for these two things, and what will happen to the lower frequency level for these two things. And based on that, the high pass or low pass filters are applied appropriately to reduce the effect of this noises or the external disturbances or to some extent, and then we try to improve the images. The typical applications of this wavelet and the multi-resolution processing is astronomy, acoustics, nuclear engineering, subband coding, signal and image processing, and that is image processing done through the signals, analog signals. That is neurophysiology, music, MRI, speech discrimination, optics, fractals, turbulence, earthquake predictions, radar, human visions, and these are the different applications where we can employ this wavelet and multi-resolution processing for the application. And next one is the compression. The compression is, as I told you in the beginning of the session, sometimes the size may not be equal for all images that we are considering for the processing. We may get as images of smaller size to the larger size. So if we are having a larger size of an image that cannot be accommodated within the storage system that is available to us, then we may have to go for the compression of the image, wherein the constraints are like we should not lose any of the information. And even if you are losing any of the information for the portability reason, we should be able to get it back for the analysis and understanding. So what are the different mechanisms that can be adopted in such cases? So the term data compression refers to the process of reducing the amount of data required to represent a given quantity of information. And data might contain elements that provide sometimes no relevant information also that need to be avoided, and sometimes data redundancy. Without probably we are not aware of that it is getting repeatedly available, but it may be available repeatedly in the thing that need to be avoided or that need to be omitted. So when we deal with the image compression, what will happen is sometimes the useful pixels that are essential for the representation of an image also may be get compressed. So this problem will be arising when we do the analysis. So when it is getting compressed, what will happen is when we do the analysis, if it is not going to be restored to its original form, if you are going to analyze the image with respect to the compressed mode, probably it may lead to the misinterpretation. And to avoid it only, we just go ahead with the even if it is compressed at the stage of analysis and understanding, we wanted to explore the originality of the image, and then we try to proceed with the image analysis. So the compression mechanisms that are available are coding redundancy, interpixel redundancy, and psychovisual redundancy, fidelity criteria. These are all very much associated with the compression techniques. And we have something called as error-free compression. The methods are variable length coding, LZW coding, and predictive coding. All these things are standard methods that are associated with the compression. And then we have what is called as a lossy compression, that is a transform coding and a wavelet coding, where the details of the pixels are going to be completely transformed into the another form. If at all, if we want to work with the original image, then we have to get back to the original form of the image, and then only we have to keep work on it. Otherwise, we will not have a appropriate interpretation level or appropriate analysis is not possible. And next one is the morphological. As I told you, from starting from image acquisition, image enhancement, image restoration, color image processing, wavelet processing, and image compression, all these particular tasks that are carried out with relevant to the image is going to produce the image as an outcome. And then you will be able to see the what sort of images that we are getting out of all this process, and definitely the visualization of those images will provide a appropriate understanding towards the image. Now, coming from the morphological processing, segmentation, representation, and object recognition part, if you see, the images are getting transformed into a number of features, and all the analysis that we are going to carry out henceforth will be respect to certain features that are available in the images. So the features are going to be analyzed. In turn, the images are going to be understood in an appropriate form. So now coming to the morphological processing, it is associated with the study of a shape in an image. Normally, it uses a structural element as a probe. It is used to remove imperfections in a segmented image and provide information on the form and the structure of the image. It's very simple. I try to represent the different part of the images are associate a different part of the image with to that of a shape which is very much familiar to me. So I call that shape which is very much familiar as a structuring element. Whether this particular portion of the image would be of rectangular for visualization or a circular for visualization. So normally, whenever you have elongated part of it, then probably we would be classifying it as a rectangular based region. Sometimes it would be of a circular base. The best example that I would say is in the defect detection portion, right? Whenever you are detecting any defect in any of the images or the image application which is meant for a defect detection. So if the size of that defective portion is little bit of elongated in nature, then probably we would be saying the structural element would be of a rectangle or a square, and so we will be able to categorize it. So this would be taking this particular defect would be taking the shape of a rectangle or of a square or of a circle, and accordingly the interpretation will be carried out. The next question is how do we conclude whether it is taking the shape of a rectangle or a square or a circle, and that's where we make use of the parameters like perimeter or area. If the area is greater than certain values, then it is obviously contributing towards the elongation of particular defective portion. And so we are concluding that to be under the rectangular type or a square type. So there are a lot of other means of interpretation associated here. So that will be taken care, and based on the structuring element, we will be designating finally what sort of a shape the particular portion or a region is going to take after the thing. And normally the morphological processor helps in the extracting the image components that are useful in the representation and description of the shape. And it provides a transition from processes that output images to processes that output image attributes. Instead of output images, it is going to provide the output image attributes, which will be processed in order to improvise the analysis of it. Maybe you can see here the thickening of the contour or the thinning of the contour will help us to understand or provide a better understandability to the images. Our next one is the segmentation, and as soon as we get into the image processing research, the first and foremost idea normally most of us will be working on is with the segmentation of it. Segmentation is extracting the foreground and the background, or maybe segregating the foreground and background of the images. Accordingly, we will be going for the analysis. The purpose is to partition in an image into meaningful regions with respect to the particular application. And of course, here the meaningful regions, first we will be extracting the foreground with the background, and then we try to conclude it for the meaningful regions. So application of image segmentation includes identifying objects in a scene for object-based measurements, identifying objects in a moving scene for object-based video compression, identifying objects which are at different distances from a sensor using the depth measurement, and from a laser range, find enabling path planning for a mobile. These are the different applications that normally we just come across with the segmentation. And as far as the segmentation methods are concerned, the first common one is the thresholding. So what is the thresholding is, whenever we wanted to focus on any of the region of interest, that region of interest need to be prominently highlighted. So how is that going to be possible? So the general concept on this thresholding is, the region of interest or the region of analysis, whichever we wanted to focus for further analysis, need to be highlighted than that of the rest of the portions. So what is that we are going to do? So the first one is a simple thresholding mechanism. Whichever region I wanted to analyze, that need to be increased. The intensity value of that particular region need to be increased by certain amount, such that the rest of the image is not that much prominent. So what is highly essential here is, what is the region boundary? Just like that, we may be knowing, visually we will be identifying, okay, in this particular scenario, the portion of this tree only have to be prominently available, the rest of the things have to be subsided. So if I wanted to know the boundary of the tree only, then I can do some certain manipulation over the pixels, and I can make this as the thing. So what will happen is, the first thing, the all segmentation method, the first thing is, what is the boundary of the region? And once I arrive at the boundary of the region, within the region, what sort of manipulation mechanisms can be handled in order to make the particular region prominently visible? The first thing is the basic global thresholding. I apply a common thresholding value, whether to increase all the pixels by certain value or decrease all the pixels by certain value. So what will happen? The prominent one, or the pixels which are at the high contrast level, will be definitely be of a prominent after applying this global thresholding. And maybe if I wanted to work on the sharp areas, this will be prominently available. So based on the locality, that is the spatial values, spatial coordinate, we would be able to exactly identify what are the different locations of prominent intensity levels, and then we can proceed. But one more thing what we need to keep in our mind is this kind of mechanism will be purely of dynamic with respect to the type of application that we are going to handle. And the second one, Wotsu method, it is a common methodology or traditional thresholding methodology, where by means of a window we will be, it's a dynamic thresholding value. Maybe I just try to identify the um, appropriate location. For that particular minimal location or the minimal number of points, I try to adopt the thresholding value. And multiple threshold. So in the image itself, we will be adopting the multiple threshold. Say for example, if the pixel intensity level are between 0 and 60, it need to be increased by this much amount. If it is between 60 and 120, then it should be increased by this much amount. And if it is between 120 and 200, it is. So that is a multiple threshold. For uniformly, whenever we come across a intensity value lying between 0 to 50, then it need to be improved by a certain level. And one thing which we have to keep in mind is if we are adoptly going to improvise the pixel level, then probably the image that we are receiving after the um, improvisation or after segmenting the thing may be completely of a distorted one, which may become a unused or meaningless for the further analysis. So that is why when we do the thresholding, we have to be careful whether there is a proper association between the different levels of thresholding, which is not disturbing the original region or the meaning of the information that is present in the particular image. That is a multiple threshold. And variable thresholding is at different time, different levels of thresholding may be required. So that is a variable thresholding. We cannot follow the multiple thresholding or common thresholding that is applicable for all the pixels. What will happen here is the time factor is so important. At this particular time, if this is the value of the pixel, this much level need to be improved. And if the time is a different, then the level to be improved may not be of this much level, it is of a different level. That is a variable thresholding. So the time factor, and only when we come across such kind of timing factor, this will be improved. Or a certain constraints. When you attain certain constraint only, this thresholding will be applied. Otherwise, the different thresholding will be applied over there. And slightly different here in between the multiple and variable thresholding is more than one threshold value will be applied based on the certain level of intensity, whereas a variable is at maybe I would say the context level. Context, based on the context, we will be trying to improve the thing. And the next one is the common thing which normally we all come across with this. This is about the edge detection mechanism. We have a lot of edge detection mechanisms like basic edge detection, like Sobel edge detection, and Privet edge detection, and Canny's edge detection, and Lagrange's edge detection. So many types of edge detections are available. So when we do the edge detection, the one thing what we need to go ahead is, are we going to process the edges with respect to first order differentiation or the second order differentiation? When you go with respect to first order differentiation, then probably the nearby 4 pixels alone will be considered for the identification, and based on that the edge will be picked up. And when we go with the second order, the nearby 8 pixels will be considered, and based on that. So whenever we wanted to go ahead with the particular region, then probably the second order would be of a very much useful when compared to the first order. So that is why if you take a grayscale image or a color image, the canny edge detection and the Gaussian edge detection would be of LOG. The detection would be of much powerful when compared to that of Sobel and Pravi. And Sobel is normally accommodating first order level of boundary identification. In some cases, in some applications, certain applications, even the Sobel would be performing well for the grayscale image as well as for the color image when the size, that is, size of the image is limited. That means if it is a 16-bit image, probably the Sobel would be yielding a better result. But if it is of a 64-bit image, then the number of combinations will be increased, and there the Sobel may not be able to detect the edges appropriately. There we may have to adopt for a go for this what is it Canny's edge detection or the advanced level of edge detection mechanism. There are a number of edge detection mechanisms are available that we all know. And the third portion of it, as far as the segmentation is concerned, the first one is threshold, which is applicable for the entire image, and the second one is identifying the edges of the particular region, and third one is within the region, how are we going to make it as a uniform region of representation by means of region growing or data clustering or a partition clustering, or the different methods are available. So the individual pixel will be modified according to the neighborhood, and so that the neighborhood, whichever you treat as a neighborhood for the particular region, would be treated uniformly, and the uniform projection will be there for the prominent representation of the region of interest. Next one is a representation and description. As far as the representation is concerned, it is transforming the raw data into a form suitable for subsequent computer processing. Normally, the representation could be of a boundary-based representation and the region-based representation. Whenever we consider the boundary-based representation, we make use of the I think I'm getting on certain doubts. Maybe after the presentation, I'll go through one by one and I'll come across with the answers. Will it be fine?
Okay, ma'am. It's fine, ma'am.
Because it won't affect the flow of presentation. Once I finish, I take up with the doubts that is raised over here.
That's what, ma'am. We can, if it's okay with you, we can conclude by 11:30. 11:30 to 11:45, we can have the doubt clearing session, ma'am.
Okay.
Or still more time is required.
I think another few more slides are there. I'll finish with that and then I'll take it.
Sure, ma'am. Sure.
And if you start answering for one query, automatically the rest of the queries also will be answered. Most of us will have a similar kind of doubts only.
Okay. Okay, ma'am, then.
Yeah. So the boundary representation is completely focusing on the corners and inflections, and the region representation, it's based upon the shape. We will take up the geometrical features as well as the texture features that are available. And description also called as a feature selection, which deals with the attributes that are associated with the images. And then on the last portion of it, object recognition, which is gaining importance as far as in today's researchers are concerned. The process that assigns label to an object based on the information provided by its description. And maybe the semantic part of it is coming into picture, and when we try to adapt that, we assign the labels to the object based on the interpreted information, and accordingly we will be going for the retrieval process. And this is becoming very much essential and very much useful for the present scenario of research. Given some knowledge of how certain objects may appear and an image of a scene possibly containing those objects, report which objects are present in the scene and where exactly it is available. So that by means of appropriate labeling, we are making it out, and that is helping us to have a better insight into a image. And recognition should be invariant to viewpoint changes and object transformation, of course, and it should be robust to noise and occlusions. So the first challenges that we have with object recognition is the same image may be taken in a different angle. Whether it is seen in elevated, that is a front-based view, or in the side view, the image is the same, which is referring to the same. So one of the challenges that we have at this object recognition is the dealing with the angle of appearance. When it is the same photograph, you can see here the same photograph in the different angle, but when the process is carried out, all the three have to be labeled as a same photo. So there is one of the challenge that we are facing with that. The second one is the same person's photo. Of course, the appearance is different, but the illumination part is different over here. One is much brighter when compared to that of the other one. So it doesn't mean it is of a different person. Both of them are the photograph of a same person only. One is taken in the dull light and the other is taken in the brighter light. And both of them are referring to the same individual only. And the third, this one is, if you just happen to see here, some sort of occlusion in the sense some illusion kind of thing. Maybe the there is some kind of stripes available on. It's not so exactly the horse is standing behind the a tree. So the appearance of this is giving some sort of a distorted
Just like a
information.
mask in the face. We are using the mask in the face, so mask is the occlusion in the face recognition. Am I right?
Occlusion means it's multiple visions. Actually, if you just from one side, if you see the tree is in front of the horse and the horse is behind the tree. The other side, if you see, it's not like that. There is going to be a mesmerized way of representation where we are not able to recognize what exactly is a portion of a horse and what exactly is a portion of a tree. In one angle, it is we are able to visualize completely as a tree as such. In one angle, we are able to see it's not like that there is a man sitting on a horse. So some kind of mesmerized visual. Okay, that how our brain is going to recognize it. That is a occlusion. Got it?
Yes, ma'am. Thank you, ma'am.
And next one is the scaling. You can see here a tall person holding a small object and a short portion holding the same object. The object size is of the same, but with respect to the background, the size is varying. It looks as if it is varying because the huge size of the person, the same object, the same size of the object is becoming very, it appears as if it is very smaller. But to my knowledge, what we are seeing is the size of the object is the same because the person who is holding is a huge in size. It is visualized as a smaller one, and whereas in the other case, it is visualized as a larger one. But the object is of the same size, and the object should be recognized as the same object only. And deformation, we all know that is something may not be very much clearly visible, and sometimes some portion is not clearly available for the understanding. But still, it is a portion of the image. And here the background clutter. If you just look into this particular image, there are so many things are available, and it depends upon the perception of the viewers how they are looking at it. and what they are looking at it. It may looks like a confused state of images, but when we look at one perspective, you find a lot of persons who are sitting together, or sometimes it looks like a flower, and sometimes it is looking like just a spill of colors that has fallen on the floor, or something like that. So different level backgrounds are there. When you remove such things, there may be some kind of a meaningful picture available. So still, the object recognition has got a challenge over here. What exactly we are trying to look at on this particular, whether it is the background or it is the foreground. And when it is a background, the background has got a lot of features to be analyzed, and what exactly to be analyzed and how it has to be represented. So that is what matters. A lot of object recognition applications, as we all know today, we are coming across. So that is there. And the next one is image classification. Once the recognition is over, what is that we are going to deal with all these things? Image classification, it is a process of categorizing and labeling the group of pixels or vectors within an image, and assigning pixels in the image to the categories, and categorization laws can be based upon more spectral and textual characters. Normally, the classification can be done based upon the statistical features, based upon the texture features, and based upon the geometrical feature. Statistical features means it is going to deal only with the mean, variance, and the median, and based upon that, the contrast level, we try to classify the images. And when we talk about the geometrical features, there we will be concentrating on the shape of the objects, whether it is of a circular shaped one or it is of a rectangular one, and based on the structuring element, we would be able to classify the thing. And as far as the texture based is concerned, it is going to deal with the different aspects, like how the pixel distributions are done, and what are the different ways it is represented, and then in which combination it is represented, how one portion of pixels are getting correlated with the other portion of pixels, and how it is deciding about the texture of the images, and so on. And a lot of classification schemes are there, and generally we all know that it is going to be of pixel based classification or a region based classification. And apart from that, we have something called as a supervised and unsupervised, and a hybrid or a semi-supervised one. As far as the supervised ones are concerned, we have a parametric model as well as a non-parametric model. Parametric means based on certain parameters we will be going, and here it's we don't have any properly defined. Say for example, if I take mean, median, and all, it's all completely parametric based. And non-parametric means geometric shape we will be taking. And unsupervised, we don't have any teachers to teach for a particular thing. Just like that, it based on the association. It is association in the sense maybe the distance or the closeness towards the intensity. Based on that, we go for the segregation. And the hybrid mechanism, it is going to be a mixture of supervised and unsupervised. Maybe a portion of it is manual guided and the rest of it of a automated one. Unsupervised, sorry, semi-supervised means you will be having a portion of input will be given as a hint for the classification, but not exactly as we do with the supervised mechanism. So the parametric models, you have maximum likelihood, minimum distance, and Mahal and Lebowitz distance. And the non-parametric models, you have ANN, SVM, KNN, and fuzzy decision tree, random forest, and parallel pipe. All these are the non-parametric model. And apart from that, you have what is called as a hybrid, where classifier ensembles and multiple classifications are possible, and k-means and isodata. I'm not going to elaborate all these models because in the ensuing sessions, you may have speakers who is elaborating on this with respect to the practical examples. And coming to the image processing applications, in the varieties of applications which we all know image sharpening and restoration, medical field, remote sensing, transmission and encoding, vision, color processing, pattern recognition, video processing, microscopic images. And specifically, if you go, it's not limited. Some of the things, whichever is highly sensitive, that only I have represented here. Apart from that, you have a variety of image processing applications that you can see elsewhere. And the tools that are available generally. Normally, we go ahead with earlier we used to deal with the MATLAB, and then nowadays more of Python packages, and the TensorFlow is also useful. And these are the image libraries that are helpful for the image processing. Some of the references, selected references. Now I can go for the
Question answers.
clarifications.
Ma'am, I have taken all the questions and I have put in the Word file so that it will be easy for you to answer at a thing. So if you stop sharing, I will share my screen, ma'am,
Okay.
so that you know you can answer them straight away.
Yeah, yeah.
Yeah, can you see my screen, ma'am?
Yeah, yeah.
Ma'am, the first question is kindly elaborate different filters and their usage once again, ma'am.
1 second, Anupriya. I'm okay.
Otherwise,
Right.
you can answer the others and we can go back to that, ma'am. Whichever is okay for you.
Okay. Say normally when you have come across filters, right? What will happen is 1 second. I'll just. We deal with the different types of filtering mechanism, and lot of filters are available. Maximum based upon the statistical features, mean, median, and so on. So what we will be doing is, if you just take arithmetic mean filter, how it is functioning is, you take the 8 nearby pixel. You just consider one particular pixel in between and 8 nearby pixel. So how this middle pixel will be modified is, you take the arithmetic mean of all these things, and then the lowermost pixel will be replaced by the arithmetic mean. And similarly, geometric mean, harmonic mean, in the statistical point of view, it has got a different one. So the first example which I have given is, you can, the same analogy can be followed for the rest of the things also. So what will happen among this 9 pixel, say for example, in the 3 by 3 matrix, I don't know whether you are able to visualize it. You have an intensity over there. And if this 9 pixels are available, any one of the pixel value is of very lower, and maybe it is not very much associated with the rest of the pixel that you have taken. Just imagine 3 by 3 matrix, and you have random values associated with the 3 by 3 matrix, and in any one of the value, if you see that it is not very much closer, or anyway it is not relevant to the rest of the 8 pixels. So I wanted to improvise that one only, so that I make this particular pixel also uniform with the rest of the pixel. So what I do is, I take the average of all the pixel and I try to replace the lowermost one with the average of it. So a slight improvisation is made out over there. That is the arithmetic mean. And in the case of a median filter, how normally we will be considering the median in a statistical application. When you are given with a set of data, we will be taking the median value, and that will be replaced. That is what considered to be the median filter. And the max and min filter is, whenever it is closer to the maximum value, it will be replaced. The pixel will be replaced by means of a maximum one. And whenever it is, when we adopt it as a minimum one, whatever we are having, the maximum one will be pushed down to the minimum one, so that we are neutralizing the effect of the images. And the same concept is adapted for everyone. Am I answered for your question? Did I answer for your question?
Yes, ma'am. Yes, ma'am. Ma'am, can we go for the other questions, madam? How
Yes,
can I
yes.
detect the color shading defect in an image?
Pardon me?
Is my screen visible, ma'am? How can I detect the color shading defect in an image?
Color shading defect. Generally, the region need to be identified, and then whenever you are representing a particular defect, that particular defect color appearance need to be captured. Maybe it will be varying between these values only. For example, you take, since I have worked with a grayscale image, I would be able to answer with respect to that. In the grayscale image, if there is a defective portion, it will be appearing as changes in the values. So the region can be extracted out, and then the uniformity of the intensity values can be ensured over there. And based on the co-occurrence of this intensity values, we will be able to designate that as a defective portion. And it is with any other color also. Is it fine? We need to find out the co-occurrence as well as the correlation between the color, and then we have to identify that as a defect.
Yes, ma'am. Thank you. Ma'am, actually, just want to know, like, I'm just working on the ceramic tile, that is the industry project. And in the reference of that, I am asking this thing, like color shading and all. So that would be applicable to that particular industry.
Yes, definitely. See, as far as a ceramic defect is concerned, whether you are talking about the external defect or internal defect.
Ma'am, external defect, ma'am.
Surface defects, right?
Yes, yes.
So as far as the surface defect is concerned, we need to carry out the textural features.
Okay.
Internal will be more or less will be similar only. You can even the pixel variations can be easily correlated and you can identify. As far as the surface defect is concerned, we need to understand how far the texture is available. So maybe you have to calculate with the angular moments and then the correlation factors between one pixel and the other pixel to find out what sort of coarseness is available, the binding is available. Based on that only we will be able to identify.
Thank you so much, ma'am. Thank you for the clarification.
Ma'am, the next question is, ma'am, we'll take just 2 minutes and we can close this, ma'am. The next question is here, ma'am, you can see here. Does the thresholding technique sense towards FAR and FRR techniques in an image too? Can you see the question, madam?
Yeah. Some sort of. Not exactly we would say, but some sort of correlation.
Okay. Ma'am, the session was very exhaustive and very informative, madam. Thank you very much, ma'am, for your patience. And like it is actually a 2-hour session, and you have been very patient in explaining so clearly each and every concept involved in the image processing and the related techniques. Thank you very much, madam, for the presentation of today.
And hope it was useful and hope the participants were able to get all the content that I have conveyed. Take it forward.
Yeah. Yes, ma'am. Please proceed.
Thank you very much. Thank you very much for the patient listening.
Ma'am, we will be circulating a feedback, and once I receive the feedback, I will share it with you, madam.
Sure.
Yeah. Thank you very much.
Thank you for the opportunity.
Thanks, ma'am. Thank you very much. Dear participants, we will have the next session starting in 15 minutes. The next session, you know that nowadays the agriculture-based problem solving is at the top priority. So the next session is going to be on applications of image processing in various fields of agriculture. And this is going to be presented by a principal scientist in the agricultural statistics from ICAR, Indian Institute of Oil Research, Hyderabad. So stay tuned in, and we will start this session by 12 o'clock as scheduled. So we are closing day 1, session 1. We are supposed to close by 11:45. We have taken 3 minutes extra just to conclude, like the question answer sessions also. And I hope the questions are answered. If you have further questions, you can post it in the chat. And of course, I have your mail IDs, and you will receive the reply by today evening by the concerned speaker. Thank you very much. Stay tuned in. Like we will get back by 12 p.m. sharply. We will not stop. We will start by 12 p.m. sharply. Thank you.
Hello, excuse me, ma'am. Hello.
Yes, yes, please. Yes, please.
Yes, ma'am. My name is Chandra. I'm from SR University, ma'am.
Okay.
So I have applied for this workshop last 1 month back, but I did
Okay.
not get any kind of mail or any clarity from you, ma'am.
Sir, if you actually, I have taken all these mail IDs only from the Atal website, sir. Like if you
Okay, ma'am.
have registered it and if you have given the right mail ID, then all must have received, because we formed a WhatsApp group, and we also mailed to all the participants. If you have
Okay,
any
ma'am.
problem still, just post your current mail ID, like whatever with which mail ID you have joined, post that, and I will make sure that you will get the information from now. Because whatever you have given, I have received some mail demons, like delivery demons, that it has not reached. So that is the scenario. If you can share your mail ID, I can help you out again.
Okay, thank you.
Yeah.
Bye.
We'll start by 12 p.m. again. Thank you all. Stay tuned.
Vice Principal and the course organizers, Dr. Anupriya, for giving me this opportunity. And uh, this is the topic. First, I would like to introduce my organization because I think I perceive that many of are from the engineering side. So just I would like to introduce my organization, what it does in 2 minutes. So our organization is Indian Council of Agriculture Research, which is established in 1929. So we are going to be completed 100 years shortly. And it is one of the largest national agricultural research system in the world. And it is an autonomous organization under the Department of Agriculture Research and Education, which comes under Ministry of Agriculture, which is an apex body which coordinates, guides, and manages the research and education in agriculture, horticulture, animal husbandry, and fisheries. We have altogether 101 ICR institutes and 71 agricultural universities across the country. And we have a good networking system called All India Coordinated Research Project System. So whatever technology we developed or we invented, that has to be tested in this All India Coordinated Research Project System of entire country. We have 65 systems like this for each and every crop, so that whatever crop develops any new technology, new variety, hybrid, that can be tested in all the centers of all over India, and then only that will be released as a variety or a hybrid or any technology to the farmers. And since 1950-51, our food grains are increased by five and a half times, and horticultural crops 10.5 times, and fisheries sector is 16 to 17 times, and milk production is by 10.5 times, and eggs it is 53 times. This is all due to this our 100 years research. We are also part of the green revolution. And whatever you can go, you can search in the Google ICR, you can go to the website, and we have one portal called Krishi portal, which it gives whatever our publications, technologies developed, and what are the mobile apps developed, whatever technology we have developed. This is the phase of our achievements, so this Krishi portal. So I request you, please go through this portal. You can get all the information, researches, applications, everything you can get in this portal. And mine is the Indian Oilseeds Research Institute. So we have 9 annual oilseeds. I think just to have a glimpse of it, I just shown the crop, how it look like and what is the seed. Like this is groundnut, and this is mustard and soya bean. We have 3 separate institutes for each of these crops, because these are 3 major crops grown all over India. And this is sesame crop, that is till, and sunflower and safflower. This safflower is like the safflower oil, you will be knowing. That is made up of blending of this safflower oil. And castor, this crop is castor, and this is nicer. We call it as ram til in Hindi. And this is linseed. Linseed is a very healthy, it is having omega-3 fatty acids. Nowadays, people are very health conscious, and they're taking these linseed capsules for so many health issues. So we have a mobile application which gives a comprehensive idea of each and every oilseed crop, from all the details, what is its scientific name, what is its importance, where it is growing, and what is the soil is needed, climate, and what are the crop management, what are the varieties, hybrids. We have put in a comprehensive manner in this oilseeds at a glance. If you want to know about the crop in details, you can go through this mobile application. This we have developed with the collaboration with the CDAC. And about my institute, we have established in 1977, and these are the crops. castor, sunflower, sesame, safflower, Niger, and linseed are our mandate crops. Our basic mandate is we will do the research for improving the productivity, oil content, and the quality of these mandate crops, and we will maintain the information of oil seeds knowledge, and we coordinate all the all India coordinated research project centers for these crops, and the developed technology will be disseminated. Yes, madam, am I audible?
Ma'am, you're audible. Please proceed,
Yes,
madam.
ma'am, you are audible.
Can I continue?
Continue, ma'am. Continue. You're audible.
Yeah, whatever the technologies we developed, we try to disseminate to the farmers, and we try to empower the farmers in different technologies by capacity building trainings. This is also brief about our institute mandate. And as I perceive that most of you are in computer engineers, so I just want to give some of our project results. We use the wireless sensor networks for forecasting the gray mold disease. This gray mold disease is appears in it is a fungal disease and castor. It is very devastating disease for the castor. It is having very short life cycle, so it is very difficult to model and forecast the disease. And it is highly weather dependent. So what we have resorted to the wireless sensor networks. As I told, it is a highly weather dependent. It depends on the temperature levels, relative humidity, and leaf wetness. So these three sensors we have made into a node, and this was deployed in the fields in the in our Telangana. It is a Mahabubnagar district is growing this castor. So we have deployed these sensor networks in the field, and we have collected every half an hour during the crop period, every half an hour, all these three parameters, weather parameters, and this will be dumped to the server through the SIM and the gateway. So based on the information we got from the every half an hour data, and based on the manual disease scoring, we have developed a weighted weather-based indices regression model, and which is augmented with some decision rules, and we started advising farmers through this advisory system. So whenever the favorable conditions occurs for the disease occurrence, we used to send the SMSs through our gray mold advisory system. And apart from this, we have developed a Telugu mobile app which is purely on this castor gray mold. In this, we have incorporated a expert advisory system. This is based on the backend is based on the machine learning algorithm random forest. So based on the information given by the farmers, the options given by the farmers, all these questions, it will predict whether it is the disease in having high risk, low risk, or medium risk. Based on that, it will give the advisory whether they have to spray the pesticide or not. This is a small brief about our project on the IoT. So coming to our present topic, this farming operations, a farming cycle consists of from soil preparation and sowing of the seed, giving some irrigation, and putting some fertilizers to grow that, and then if the crop grows,
Ma'am,
yes,
madam, your voice is breaking, madam. Can
now
you
it is
please
okay.
check? Now it is okay, ma'am.
Okay. So this farming cycle consists of all these operations. First, we have to prepare the soil and sow the seed and give the irrigation and some fertilizer inputs for the growth of the plant. And the pest management, time to time crop management we have to do, and finally the harvest will be taking up. So one way or other, in all these operations, we can foresee the application of the image processing. So I'll try to give few examples, and where we can apply this image processing, and some case studies or research works done in that particular field. The first one is when we are going to sow the seed, we should have the pure seed. So the major thing is when we get a farmer gets a seed lot, or a breeder get a seed or seed certification get the seed lot for they will examine what is its germination percentage. Germination percentage means out of 100 seeds, how many seeds are germinating. So this is most crucial, because unless these seeds are pure and they are all viable, the optimum yield we cannot get. So usually farmers, what they will do is they will soak into the water, and based on the specific gravity method, all the chaffy seeds will be floating, that will be taken out. And if in the breeder's perspective, if they want to use that seed for further crossing programs or for developing some other varieties, hybrids, they have to know what is the purity of that seed, and whether it can germinate uniformly or not. So they will use that paper towel, germination towels, and they will see what is the germination percentage. And it is very time consuming, and if we have to check lot of seed lots or so, it is very labor intensive. So here we can use this image analysis, so that the germination can be classified, whether the seed is germinated or not germinated, based on their shape, color, and textural features extracted by the image. And this can be made into an application. We can give it to the end users or stakeholders, so that they can see when they put some hundreds of thousand seeds into the application, they can see which here they have developed the rice seed germination evaluation system. It is a sort of germination prediction software. What they have done is they if the image is acquired through digital camera or mobile phone, this will be fed into this evaluation system. The output of image will give where the chaffy seeds or defective seeds are there. So that can be discarded. So this is the what is the process flow. What they have done is they acquired image, and reprocessing was done, and they extracted the features like color features, morphological features, textural features, and based on this they have put the germination evaluation, and the results will be presented. So this seed image segmentation they have done, so that it can be separated, like they have used artificial neural network model. So what they have done, before the data has been collected by beforehand, they know what is the chaffy seed and what is the good seed. That information was fed into the same seed was taken as images, and that information, that 18 extracted features were put into the ANN model as input, and there are 13 nodes, hidden nodes, and finally we got the output whether it is a good seed or chaffy seed, or it can be germinated viable seed. So the system precision here they got is the false positive rate is 7.66 and false negative rate is 5.42. They have tested with 34,000 images, so it is quite reliable system, I feel. And another method, the testing the seed purity is the grow test. Grow test is nothing but they see instead of lab, they will grow the plants in the outside, and they will see the uniformity of the plant grow from the seed to the till the end. So what they have done is this is also a very subjective and based on the human vision by seeing the seed, whether it is a chaffy seed or viable seed, it is very subjective method. So here also we can use this image analysis. They have taken the 2 rice varieties and 2000 seed samples were taken, and they have extracted 14 morphological characters and color characters, and this purity of the seed also compared with the grow out test. So before the data set was built like that, some of the chaffy off types or chaffy seeds also added to the. So here you can see the off type percentage also, it has been calculated with the image through image analysis. They have done the discriminant analysis so that the accuracy they got for the shape parameters or shape features is 99.2. So it can discriminate the true types and off types very high with high accuracy. But color, it is a little lower, is 93.55% accuracy. So here we can see the grow test for color morphology, it is failed to detect the off types. But in the image analysis, you can see it can it is detected the off types. So the human eye cannot see this image can be detected. So this image analysis can be used for the grow test or seed purity tests. And somebody in the chat box, they have put they have lots of seed and they want to see the seed quality. Such type of analysis also, you can extract the seed features like morphological characters, textural features and color characters, and that can be put into a segmentation or any segmentation technique or artificial neural network classification, and you can easily classify the seeds which are true types and off types. So after coming from the seed, when we grow the seed in the field, the crop will grow. It will cover the land. So the crop canopy cover, what we call is the percentage ground area covered by the crop. So it is an indicator how much land is used, how much land degradation is there, or land desertification is there. These are all in the government. They want to know how much deserted land is there, like that. And it also, this canopy cover also helps in crop yield prediction. So all this will help in to know what is the crop establishment. So unless we have optimum plant population per hectare, we cannot get the maximum yield potential. And unless we have a good germination percentage, we won't get the final good yield. So when we detect this germination is not good, then we can resow where the gaps are there. And this also helps in the crop monitoring. We have to monitor the crop and observe the crop growth stages so that any deviation or any diseases are occurring or any other deviations are occurring in the crop, that can be detected. But all this usually we do with the field surveys, and the crop yield will be estimated using crop cutting experiments. They randomly, they have a certain procedure, the crop cutting experiments. Based on that, the statistical procedure, they will do the sampling and they will estimate the yield. And sometimes remote sensing data also used for this estimation of this crop yield. But all these are highly labor intensive and time consuming. So this estimating of plant emergence or plant density estimation, or plant counting in different growth stages, or yield estimation. In all these aspects, we can use this image analysis. So I will try to give one or two examples for each of these applications. So here they have seen the crop density in the early stages, so that they know what is the stage of the crop. So usually, as I said, it is a manual counting method which is labor intensive and time consuming. If there is in Brazil and all, they have hundreds of hectares, larger area. If it is very difficult whether the crop is grown uniformly or whether there is any aberration in the crop growth. That and all cannot be observed manually. It will take time. So here in this aspect also we can use the image analysis. In this work, what they have used is high resolution cameras, and they have taken different plant densities, and they have taken the images. Like this is the process they have followed. They have taken the original image, and they have classified and calibrated, and they have detected the rows, and the row labeling was done, and based on that ANN was trained. So the algorithm identifies the rows successively and detects the connected components, and the green pixels which they have corresponded to the plant used in the object features, and ANN is trained to estimate the number of plants in each object, that is in each row, and the relative error is 12% for estimating this weed plant density in the early growth stages. This is one application for estimating the crop density. Another one is plant counting. Plant counting, it helps us in the final stages, in the harvesting stage, before harvesting stage, to know what could be the yield from this crop. So here they have used UAV, unmanned aerial vehicles, and this digital images was taken in a 0.5 to 1 meter height, and this is coupled with CNN, convolution neural network, and they used this for counting the planting of maize or corn plants. So they have taken 50 images, 25 for training, and 4 for validation, and 21 for testing. So the testing data consists of again 3 plant densities, like per hectare, like 45,000, 60,000 per hectare. The density of the crop plant population increased so that they can estimate what is the yield potential, how much optimum plant density we can have in a hectare area. So they have taken, it's an experiment, they have taken 3 plant densities per hectare, and they have taken the 3 leaf stages. They call all vegetative stages as leaf stages, and the drone is also taken with the 3 heights. So the ground part and plant part is segmented with the LabMe software, and CNN use it for the segmentation, and opening morphological operator is used for separating the neighboring plants so that counting can be done, and segmented image, the block detector is used for segmented image to quantify the number of plants. The average difference between, and one thing we should keep in mind, whatever data we are collecting through images, we should also collect through manually or through ground truth data, so that we can compare both the data sets, which one is giving the more accurate, and sometimes we have to feed the output data along with input data like for prediction classification techniques. So our manual data also should be taken simultaneously along with the image data. Here they have taken the average difference is only 7.3%. They have assessed 45,000 plants. Based on that, they have got 7.3% accurate error. So another thing is in different growth stages also they have to know what is happening in the field. As I said, in US and Brazil or Australia, they grow in hectares. Like maize is grown in hundreds of hectares. So it is very difficult to monitor the crop. So what they have resorted to this image analysis, CNN. Here what they have taken, they have put these cameras in at a 5-meter height and with a 60 degrees angle, so that it will cover the maximum land area, and the pictures will be taken with every hour, and this has been sent to the computer. So they have used segmentation method APHI, which is robust and not sensitive to the outdoor luminosity and complex environmental elements. And they are also compared with the manually collected observations. They got highest performance, like 96%, with a very low standard deviation from the mean. This is one example for studying different growth stages. And when the crop is growing over period, simultaneously the unwanted plants or weeds will be also growing along with that. So this unwanted plants causes economic losses, and which decrease the productivity, and it is difficult to harvest the produce because all other unwanted plants also will come along with the crop. So this knowledge of these weeds and identification which sort of weed is there, and how much density it is growing, all these are important aspects for controlling the weeds, either by using manual weeding operations or manual weeding operations or herbicides applications. So here this is also a laborious process. Sometimes identification, if the weeds are so mimic with the plants, so it is a visual observation also, sometimes it is not possible. So here in this aspect also we can use the image analysis. So they have so this automatic identification of and classification of weeds helps the farmers or any industries which are growing in large scale for detecting these weeds. They here in this research work they used this this software, and they used the super pixel algorithm for visual classification and classification whether the presence of weeds in the photographed area or not. So these are the different cases like broad weeds and crop and land. All these classes manually they have made, and they have taken the images, and that they have the extracted features were put as input for the convolution networks, and these are already also they have compared with the other machine learning algorithms like support vector machines and AdaBoost and RF methods for classification of these broad-leaved weeds, grass weeds, soybean plants. They have used in the soybean crop, and they have achieved this 98% accuracy with this software. And this is one more real-time weed detection example. What they have done, they have captured the video from the crop field and they extracted different frames of the video, and they reconstructed the plants. And they trained the machine learning algorithm so that it will classify the weeds and the true plants. So this can be used in the real-time weed detection by taking the this application to the field. Here you can see the how the CNN and ResNet performed with the different data sets. They have done with the already present database with the in the public domain, and using other external data, and also they have collected the cucumber image data, crop images, and onion crop images also, and they have seen that 90% accuracy was got with the ResNet 50 network. So like this, the weed identification and classification can be done using the capturing the video directly in the field. We can see this is one sort of end user application, I feel. Then after the one more important thing is yield prediction. How much yield we have the crop will give. If we get the if we know how this is the prediction yield, predicted yield, so that they can be ready for engaging the labor or any other aspects, marketing aspects, where they can get such sort of aspects also can be known ahead, so that they can prepare well before harvesting. So here what they have done is they have taken the RGB cameras to the field like this. They have made like a cycle sort of thing. It was go it was traveled into the field, and the camera is mounted on the top in a certain angle so that it will cover the whole plot area, so that the whole image can be obtained. They have taken 10 varieties and 3 fertilizer treatments, and so that the differences of the fertilizer, the effect of the fertilizer on these 10 varieties they have studied using this image analysis. They have after acquiring the images, they have pre-processed and they have made a spike. They have taken the spikes images, and they have annotated the data. They call it as spike data set, and they have they have made the convolution neural networks utilized for getting the what are the number of spikes in that, and what is the density of spikes, and classification probability of the each plot. They have taken from images from each plot. So they have taken 4 this region based CNN models. They have shown 88 to 94% accuracy. The best model was taken for the spike variation in the these 10 wheat varieties studied. So this is so in yield prediction also we can utilize this image analysis. The another most important thing while growing the crop, the nutrient deficiencies, like there are the nitrogen, phosphorus, and potassium. They are called as major nutrients. These nutrients will help the vegetative growth of the plant, and secondary nutrients like calcium, magnesium, and sulfur. Like the sulfur, it helps in the increasing the oil content, and other micronutrients they requires only in small amounts like zinc, boron, copper, iron, molybdenum, etc. They only need small amounts, but when the deficiency comes, there will be stunted growth or chlorosis. Chlorosis is yellowing of the leaves. The leaves will be become pale yellow, and stunted growth will be. But this chlorosis is highly difficult to distinguish with the pest damage. Like sucking pests, they um, extract the sap from the leaves, and it will become discolored. So it is very difficult to distinguish between whether it is a pest or disease damage or nutrient deficiency. These are the certain studies. Very few studies in this area, because the nutrient deficiencies, collecting the data on nutrient deficiency is very difficult. They have to artificially create that nutrient deficiency in the crop, and then they have to get the images. These are the some of the works done, like in bean, maize crop, oil palm, rice, cucumber, and they have done the nutrient deficiency analysis. And the most important part is the pest management. The pest, we can define anything which cause yield losses to the crop. Like it may be insect pest, it may be diseases like fungal, bacterial, viral, microorganisms, even weeds, we call it as pest. And other small animals like rats, bandicoots, they will also causes yield losses to the crop. So in world there are 10,000 insect pests, 30,000 weeds, and diseases are around 1 lakh, and nematodes around 1,000. But all these are not major pests. 1/10 of these pests are considered as major pests, and which is destroying 1/5 of the total world production. That is 20% of the water production was destroyed by these pests. So we can imagine how much loss is happening. Here some hypothetical example they calculated around 35,000 US million dollars will be loss, estimated loss per annum. So that much loss will be there. And what are the issues in the pest management? Lot of research is going on to control the pests. Some integrated pest management modules are developed, and for each crop, in-depth pest management systems or pest management control systems were developed. But it is very there is a lack of flow of information from lab to farm, and we are very few scientists or few experts cannot reach each and every farmer on time, and but the crop needs fast and on time support to protect the crop. So there is a large gap in between the knowledge generation and the dissemination. So what they envisaged is access to the information at right time. If they get the right time, what is the advisory, what we should do with some pest or disease is there in the crop, that improves at least 20% of the production. So because of this issue of asymmetrical flow of information, the actual developed technology is not reaching to the farmers. We have to develop a good interface between the farmer and information. So if we use this image analysis, AI algorithms, cloud services, and make into a on-time advisory systems, if we can develop a platform that helps the farmer on-site identification, that inside when he is in the field, he should identify the pest or diseases just by uploading a photo, and receives the corresponding advisory within no time. that will change the agriculture scenario. The lot of research work has been done in this plant disease and pests based on the images, because many open source data sets are available. These are all the open source databases. You can get the different diseases data sets, and many number of papers were published using these data sets.
Ma'am,
You can
sorry
see
to,
I have given number of references
Madam,
by there are so many review papers, and they have classified the diseases using deep convolution neural networks, and lot of research has been put into this pest and disease image analysis. But the major lacuna here is, you can see here so many models they have developed, um, um, and for identification of these diseases and pests. But major lacuna here is, it is not reaching to the farmers. It is only making as an academic paper, or the actual stakeholder is not getting benefited out of this research work. So that has to be taken care of when we are starting a project on this. The application oriented research should be done so that it will reach to the stakeholders.
Madam, can you hear me, Madam?
Yes.
Madam, can we reserve last 10 minutes for a question and answers, Madam? Like if you see in the chat window, faculty members, they have posted some questions. They wanted your expert advice, Madam. So, so last 10 minutes. Now it is 12:46, Madam. Can we
Okay.
conclude by 12:50? And from 12:50 to 1 o'clock, we can have question and answer session, Madam. Is that okay, Madam?
Okay. Okay.
Okay,
I'll
ma'am.
try to finish.
Yeah, ma'am.
Okay. So whatever I told, these are the issues. Some mobile apps they have developed, but these are they are not at the farmers level. That cannot be understand, like plant ticks, crop ticks, veg pest ID. So many are there, but it is not at the level of that was not reached to the farmers level. Because information in the local languages, we have very diversified languages, traditions, and all. So, if we develop applications in local languages, that can be adopted by the farmers. This this is also one yield prediction at the, they have taken the early yield prediction, so that for harvesting and marketing the fruit industry, they have used two back propagation neural network models, and these are the descriptors they used. So all these descriptors are put as an input to the this neural network model, and two models they have developed, and you can see the difference or mean difference is very very less, as that is very close accuracy they have got for the yield prediction. And one more application we can think of it is in dust testing. There is a plant protection of plant varieties and farmers' rights. Act was put by the government of India based on the International Union for the Protection of New Varieties of Plants. In farmers also, they will identify certain varieties, local varieties. They will be growing from the years together, generations together. That rights we have to protect. But when when it has to be registered into the this PPV and FR Act, it should qualify certain features. That is called DUS testing. That is, it must be distinct from the available varieties, and it will grow uniformly, and it will be stable. It can be repeatable over generations. It should show the same features. Then only that will be enter into the register, into the PPV and FR Act, and that will be used, that will be protected even the variety is extended. So mostly this, there are certain features for each crop they have defined, morphological and biochemical characters, and this is also a very labor intensive process, whether subjectivity will be there. The human vision error may be included in the justification, whether this variety is distinct from the farmer given variety, whether it can be registered or not. So here also the intervention of the image analysis, which reduces the laborious manual inspection. There are they can extract color, shape, and texture measurements. The one such example is they have taken 20 groundnut varieties, and 2,000 seeds were taken with the images were taken in the flatbed scanner, and they have taken the front end side of the pods and taken like extracted 37 statistical features and 6 dust features, and they used Fisher's discriminant analysis, so it could discriminate the different varieties, different varieties based on these features. These dust features have high discrimination ability, so this can be used. This model, the SPM classification, they have got 90% accuracy. So this model can be used for the dust testing. Similarly, for varietal identification, they have compared 28 rice varieties using flatbed scanner, and here we can see the manual and software. They have developed a software that will read all the size, shape, and textural features, and they have seen what is the exact correlation. They have done the correlation, which is almost near to the manual readings. So such sort of applications also we can do in the dust testing varietal identification. And this is the last one, I feel. There, even in edible oils, we have there is a mix. Adulteration will be there. So one study they have seen what is the feasibility of using this image processing and artificial neural network for detecting the adulteration. What they have purposefully mixed sunflower oil and canola oil to the sesame oil, and they have extracted 12 color features, and the ANN was trained with 1 to 20 hidden nodes, and they have compared these different ANN models, and the best topology for sesame oil, sunflower, they have with these 6 internal hidden nodes, and for sunflower, sesame oil, and canola, this is the topology they have chosen for the detection of the adulteration. So finally, to conclude that the image analysis and making an application, it is a multidisciplinary work. We should have domain knowledge also, and because this agriculture is highly dynamic, weather dependent, and expression of the object of interest. Suppose if you are taking the disease progression, it will be varying based on the weather also, and from region to region. Suppose in Telangana, the disease progression will be more because of the favorable weather conditions. In Gujarat, it may not be so. So based on the such variations also we should take into the account. And the major hurdle is we are having only taking only small training and testing data sets because we have to take the images and also ground truth data for comparison. So, and there are so many difficulties in image capturing also, the illumination, shadowing, while taking decisions, there may be crowding. Because of all these, even though so much of image processing filtering techniques are taken up also, there may be some errors in the features extraction. So we have to test as many possible models to obtain the maximum accuracy. And this output should be translated as a ready to use application so that the stakeholders can be benefited. These are the references what I used for the presentation. Thank you. I'm done.
Thank you. Yeah, thank you very much, ma'am. We could understand the different research aspects, the open research problems that are available in different oil seed crops and different tools that have been in use. And like it was quite informative, and like we could see more research opportunities that are available in the field of agriculture. It was really very informative and very valuable information, madam. Thank you very much. Ma'am, right now we have some questions, like the faculty members have posted, in the chat window. I'll share it all together so that you can answer them, answer those questions to the faculty members. Just a minute, ma'am. I'm sharing the screen.
Okay.
We can, ma'am, we have 4 to 5 minutes left for the, what is that, question answer session. You please try to conclude within that, madam.
Okay. Okay.
Yes, ma'am. It starts here, ma'am. Can I have opportunities to collaborate and working with your institute, madam? This is the first question, ma'am.
Okay. Certainly, based on the research work you want to do and what is your objective and whether it fits into our mandate or not, all such sort of things we can work out.
Okay, ma'am. Why
Yes.
to make the system more tedious using machine learning random forest? Why can't we switch over to DCNN, which will perform better, overcome the complexity?
Because like seed quality aspects and all, if it is better to use the extract the features and use the machine learning algorithms, CNN and all deep learning techniques, it is a sort of black box. We will there also features will be extracted, but we don't know which are needed. Like if we extract some hundreds of features can be extracted manually, like with the feature extracting methods, and we can put in the CNN also feature extraction layer also. But we don't know which factors, which features are important for the our research problem. Like suppose texture is important, textural features are important for our research problem. We don't know in the CNN which features are really extracted and all. So I feel it is better first we know which are the important features required for the object or our objective, and then those features can be extended to into the CNN. So at the first instance, it is better to go for machine learning algorithms than the deep learning.
What is UAV digital image?
This
The next
this
question,
is
ma'am.
it is like drone. Already somebody answered. The images will be taken using the drones that will be fixed in the drone.
Fine, ma'am.
Yes, ma'am.
Then the next question is, can you tell me the recent algorithm usage in agricultural area? I think you have discussed enough on that, ma'am. You want
Yeah,
to answer this?
there is no particular, based on our research problem, we have to make the algorithm, or some already like AlexNet. If it is the same purpose you are using, the same thing, already so many AlexNet, SpikeSegnet, so many algorithms are available. If the same purpose, if you are using, the same algorithm can be used in your case also.
Yeah, I think the rest all are almost similar, ma'am. You have discussed about the different algorithms, different research topics, recent algorithms. I think these are same questions which have been answered. And they are asking a few research topics which we can take up in agriculture. I think this is the last question, ma'am.
All those applications what I have put into the presentation, there are n number of, some only few I could discuss with in the presentation, but there are so many others like in the soil seed quality, seed like fruit grading also they will use, and chlorophyll content, what is the chlorophyll content they will use, even in the genomic, at the genomic level also, in QTL detection, or so many, in n number of applications you can use in the agriculture, this image analysis. But caution should be taken that you should also be involved in the, what is the domain area you are working, what for you are working. You should be close contact with the domain experts and what it is going, and you have many number of discussions. Then you apply your image analysis, CNN, whatever it may be, and you should try to bring a ready to use application. Then only the whatever research you are doing, that will be helpful to the farmers. I think,
Excuse me, ma'am. I have a doubt, ma'am.
yes.
Ma'am, you were telling about the weed detection, right, ma'am? Weed detection research areas. So in that you were telling about the image acquisition. So for image acquisition, should we use any special cameras or digital cameras are enough, ma'am?
Now here I try to give all the examples with the digital cameras, mobiles only, because
Okay.
these are most easy to acquire and not expensive. So the mobile cameras can be used. The
Okay.
mobiles or digital cameras can be used with good resolution.
Okay, ma'am. Ma'am, then you told about the labeling also, right, ma'am? So is image annotation needed for, is it mandatory, ma'am, image annotation, or without labeling also can we proceed?
Image annotation is required for, suppose if you are classifying the seed quality, like it is a seed, viable seed and chaffy seed, such sort of things, image labeling is required. And if you are using for prediction,
Okay.
the features for each image, so then also we need labeling for each seed image, suppose if you are taking. So for each seed, what is the corresponding input, output also we have to match for developing the model.
Okay,
So
ma'am.
in certain cases, labeling is needed.
Okay, ma'am. Clear, ma'am. Last question, ma'am. You told about the ResNet pre-trained model, ma'am, for weed detection. So is ResNet very efficient, or we can use any other pre-trained model also, ma'am, for weed?
Whatever, means I'm also a beginner, but ResNet 50 I have seen in many research works, that was performed better.
Okay, ma'am. Okay, ma'am. Thank you. Thank you so much, ma'am.
Thanks, madam. Thank you very much, ma'am, for your patient answering. And I hope, I think all the questions have been answered. And we are also short of time. Thank you very much, madam. Thank you very much.
I also thank you for giving me this opportunity. I also learned so much for presenting, for preparing this presentation. Thank you very much. And
Thank you.
maybe this training program also helps me in learning the image analysis techniques, CNN and all. Thank you. I'll
Thank
be
you.
attending maybe most of the sessions. Thank you.
Please, ma'am, please. The link will remain the same for next 5 days, ma'am. So you can utilize the link. Participants, see, we do understand there is some concern, like in the feedback. So please have patience. We are all matured people. So we will share the link to you again. Okay, I think it is shared also. Please check. If you are not able to, please get back to us, and please, be patient in getting things done. Okay, we are also working on it. And you can see one session, that is feedback link is posted for day 1, session 2 feedback link is posted. Kindly make sure to fill in the feedback form. Also, I have posted the assessment for day 1, session 1. Assessment for day 1, session 1, which will have some 10 to 15 questions of objective type, which you can, fill it to know. It carries no marks. It's only for your assessment. So please do not, keep it in reserve. Try to complete it by 1:30 p.m. You can have your lunch and we can start the session 3. Okay. So to give a preface of session 3 and session 4, it's going to be on the image annotation and enhancement techniques, and there will be a hands-on session on image enhancement technique. So session 3 and session 4 will be presented by Dr. K.G. Suma, Associate Professor and Placement Coordinator in KL University. So we will start the session by 2 o'clock. The session will go, first will be, session 3 will be an 1 hour session. Followed by that, we will have a 45 minutes hands-on session. Now, coming to the hands-on session, as I have posted already in the WhatsApp group, you will be using the Python. So you can install Jupyter Notebook, and you can have the Python with the Anaconda, so that you can practice, you can also practice along when the speaker is trying to explain the exercises. Okay, thank you very much. Let us all meet by 2 p.m. again. Thank you. If you are not able to complete the feedback form, we will post it again. So we are closing the meeting and we will meet again by 2 p.m. Thank you. If you have any concerns, please post it in the chat window. I will attend to it.